Hello and welcome back to Calero Academy. Today we'll be doing an algebraic problem from the diagnostic test of the online school called Art of Problem Solving. The question states, factor the polynomial x to the power of 6 minus 1 over all the reals, which is basically saying factor this as far as you can. So, before we get into the algebra side of this equation and go factor it, let's try to get an idea of how this function looks geometrically on the Cartesian coordinate system. So let's draw a Cartesian coordinate system. We have our x and y axis, y, x, and our origin. So, by casual inspection, we see that the roots of this equation will be minus 1 and 1. Plug it in and we have y is equal to x to the power of 6 minus 1. For x to the power of 6 minus 1 is equal to 0, a root, when x is equal to minus 1 and 1. Then we have 1 minus 1, 0. So, minus 1 and the 1 are the roots of the equation. Now, let's try to find the minima of this equation and some other attributes. Using a little bit of calculus, we can see that on the interval from minus 1 to 0, we have a decreasing function. And on the interval from 0 to 1, we have an increasing function. We can see this by using a little bit of calculus. We take the derivative of the equation, and we have 6x to the power of 5 is the derivative of the equation. So when this is negative, the equation itself, the function itself, will be called decreasing. And if a function is decreasing constantly on a certain measure, so it's decreasing only on a certain measure, it's called monotonic. M-O-N-O-T-O-N-I-C, monotonic. So, when is the derivative negative? We see that it'll be negative between minus 1 and 0, because then it'll be negative at a negative number inside x. We have a negative number times 6. So that will be negative. On the positive side, which is from 0 to 1, plug a positive number into x, take it to the power of 5, you still have a positive number, times it to 6, you have a positive number. So therefore it's monotonic on 0 to 1 too, increasing from 0 to 1. Now, because let's now, from common sense, we deduce that the global minima will be right here, at x is equal to 0 and y is equal to minus 1. This, we can intuit this because it's sandwiched here as negative, and then suddenly it just turns increasing. It goes negative, then it turns increasing immediately at this point. So we have a suspicion that it will be a minima. I don't want to get into too much calculus here, so we can of course find out that this is the minima just from calculus. Now, moving on to the algebraic side of the equation, let's now try to factor x to the power of 6 minus 1. Now, let's first look at a simple equation. Let's try to look at x squared minus 1. Now, everyone knows how to do this. X squared minus 1 is equal to x minus 1 times x plus 1. We have x squared minus x plus x minus 1, which is equal to x squared minus 1. Let's try to do something similar over here with x to the power of 6. So instead of having x here being multiplied to each other, let's try x cubed. So we have this x to the power of 6 minus 1 equal x cubed minus 1 times x cubed plus 1. Let's see, that's equal to x to the power of 6 minus x to the power of 3 plus x to the power of 3 minus 1, which is equal to x to the power of 6 minus 1. So we can get rid of that silly quotient sign. So, we now know that x to the power of 6 minus 1 can be factored into x cubed minus 1 times x cubed plus 1. But this is not over yet. Can we factor this? do we know how to factor this? X cubed plus minus 1, x cubed plus 1. So now we're going to do something called algebraic division. What we're going to do is that we're going to try to see if we can divide this thing any further. Take a moment and look at it. I'll give you a chance to see if you can see it. Have you got it yet? Okay, the trick is, it seems obvious that somewhere in this equation it's going to be equal to, you're going to have a factor of x cubed minus 1, which is x minus 1. Just seems obvious. Let's take it as a guess, okay? And for x cubed plus 1, it seems like a neat guess that there will be a factor somewhere, x plus 1. Let's try to follow that guess, and we see. Let's try to divide x to the power of 3 minus 1 by x minus 1. So, does x minus 1 go into here? Let's try x squared. Like normal long division, we have x squared times x minus 1 is equal to x cubed minus x squared. Now, minusing, we have that is equal to minus 1 plus x squared. Does x minus 1 go into there? Let's see. This is simply equal to 1 plus x. X minus 1 times 1 plus x is equal to minus 1 plus x squared. So we have x cubed minus 1 divided by x minus 1 is equal to x squared plus x plus 1. So now we can rewrite x to the power of 6 minus 1 is equal to x cubed minus 1 times x cubed plus 1 as x to the power of 6 minus 1 is equal to x minus 1 times x squared plus x plus 1 times x cubed plus 1, of course. Now let's try to simplify for an x cubed plus 1. Doing our trick of division, we have x cubed plus 1 divided by x plus 1. So, does x plus 1 go into x cubed plus 1? Let's try x squared times x plus 1. So we have x squared here. Now x squared times x plus 1 is equal to x cubed plus x squared. Minusing this from this, we have 1 minus x squared. Does x plus 1 go into 1 minus x squared? Yes, it does. It goes into there with 1 minus x. So we have x to the cubed plus 1 divided by x plus 1 is equal to x squared minus x plus 1. So therefore we can rewrite x to the power of 6 minus 1 is equal to x minus 1 times x squared plus x plus 1 all times x cubed plus 1 as x minus 1 times x squared plus x plus 1 times x plus 1 from over here times x squared minus x plus 1. And there, we've factored x to the power of 6 minus 1 as far as we can, because if you look closely at these things later, you'll see it's actually impossible to factor these using the reals. You can go dirty, I think, and go complex, but they ask you to stick in the reals, so let's stick in the domain. So, what we've learned is to, when we try to divide something like this, you have to try a couple of times to make a couple of guesses. I tried to, for about 5 minutes, think of ways to normally factor this, but didn't work. So I had to try some guesses. This was actually my 4th guess, and it worked. So, you have to experiment when you reach dead ends. This has been a Calero Academy production, and thank you for watching. If you have any comments, just post it in the comment section, and if you have a question you might want for us, post it in the comment section and we'll possibly do a video for you. Be on Calero Academy. Be on it. Thank you, and